In this video, we're going to look at the amplitude and period of our functions. We're going to start off with the sine function. Now, the amplitude of a function, if you like, is the height of the function, but it's defined very particularly. The amplitude is not the full height of the function. So for example, the full height of this function would be the distance from +1 to -1, which is this height here. Now that is not the amplitude. The amplitude is only half that value. So the amplitude runs from this point here up to this point here. Now this is one of the things in mathematics and physics that you have to memorise. The amplitude of the function is not the full extent of the function, it's only the half the height of the function. Now we're also interested in the period of a function. So what do we mean by the period of a function? Well, you can see that this function here repeats. So it gets to this point here and then it repeats again. And also if you go from this point back, you can see it's going to repeat. Now functions that repeat, we call them periodic, and they repeat each time after a certain distance. So in this instance here, we know that the sine wave repeats after every 360 degrees because we go around 360 degrees and then we repeat that same process. We go round again and again, and this is what generates a sine function. But you can see here, in this instance here, the repetition here is somewhere just above 6. In fact, it's approximately 6.28 because the scale here is in radians. So it's 6.28 radians, which is 360 degrees. So this is the amplitude and this is the period. Of course, we could choose different points in order to represent the periods. For example, we could put it up at this point here, and we can see the repetition then occurs at the next peak. So again, this is the same period of 6.28. Or alternatively, we could choose any random point along the curve. So for example, we could choose this point here, and you can see that the next point along where the curve starts to repeat is going to be along here somewhere. And again, that is a period of 6.28 radians, which is 360 degrees. So that's the two things that we want to cover in this video, are the amplitude and the period. So let's have a little look at this in a bit more mathematical detail. So we have our sine function here, and we know that the amplitude is given by this blue line. Now let's say we call the amplitude a value of A, and we know that this is the period here, which is the green line, and let's say we give the period a value of B. Now in this instance here, the amplitude is a value 1 and the period is 360 degrees. But of course, the actual axis here on the x-axis isn't in degrees, it's in radians. So it's 6.28 radians, which is 360 degrees. So if we were to write our function out, we would have the y height here. Now the y height is given by the function f of x, so don't get confused in this. I put this down deliberately like this. The y is the height, which is just the same as f of x, which is the height. If you like, the y and the f of x are interchangeable. They mean the same thing. So our function is going to be our function a for the amplitude times sine of the period b times x. So in this instance here, a is a value of 1 and b is a value of 360 degrees, or it's equal to 6.28 radians. Now what we're going to do is we'll go back to the simulation and we'll put this function in, a sine bx, and we'll see how we're able to change the amplitude and the period of the function. So I've opened this up so you can see me typing the values in. So we're going to have a function f of x is equal to sine x. Now, as we said before, that's the same as saying 1 times sine x, and we could also put a 1 there, so it's 1 times x. Now, this term here will give us an amplitude, and this term here will give us a period. So we're going to replace the amplitude with the value a, and we'll replace the period with the value of b. So now we've got these sliders here, and you can see that we can change the value of a. So at the moment, the amplitude of a is 1. So from this point here up to this point here is a value of 1. And we can change that to 2, and we can change it all the way up to 10, and we can work our way down to make it a value less than 1, for example 0.5, and you can see the amplitude now is half of what it was before, so it's an amplitude of 0.5. So that's quite straightforward. Now we'll replace this back to a value of 1, so we're back to the normal sine function, and now we're going to have this value of b. Now we said that this is going to adjust the period, and we know that the period of a sine function is 360 degrees. So let's just for the moment deal with degrees. So if we were to increase this value to say a value of 2, then you can see it has the effect of squashing the function in the x direction. So you can see if we increase it to a value of say 3 or 4, you can see that the period is changing. But you can see that as the values here go up, the period is decreasing. Now that might seem a little bit counterintuitive. You might be looking at this and saying, well, wait a minute, if I change that to a value of 2, doesn't that mean that the period is going to be 2 times x, so it's going to be twice as much? Therefore, instead of it squeezing the function, you're expecting it to stretch the function. But that isn't the case, and you'll see that if you actually put some values in. So let's put some values in now. So let's put our original function in, which is sine x. So you can see here that if we were to pick some point, say along here, then at this point here we would be looking at the value of sine of 2x. So it would be the value of the sine of twice this. So we would go from this point here to this point here. So the value for the sine at this point is actually a value of 1. So you can see as we get along to this point here, the height is going to be given by a value of 1, which is the height at this point. So take your time and have a look at that and rewind the video and convince yourself of that. Now, if we were to go to a different point, say we went to this point here, then we would be looking at the sine of 2 times this distance. Well, 2 times this distance is this point over here, and the height of the function is 0. And you can see here at this point the height of the function is in fact 0. And you could go across and work our way along each individual point all the way along the curve. And when you do that, you'll see that the period of this function halves as we double this number, and it would go down by 1/4 if we were to make this go up by a value of 4. Now, if we look at it in the other way, if we were to change this to a value of say 0.5, then you can see that the original function here is in green and it repeats at 360 degrees, but this function here is now expanded. So rather than it repeating at 360 degrees, it's going to repeat up here at 2 times 360, which is 720 degrees. So we can adjust the period of this function by adjusting this number. And we can adjust the amplitude here by adjusting this number. So let's just run this and you can see it running together. So that's us able to adjust the amplitude and the period of our function. Now we will go over a few more examples of how to use this, but just as a quick first example here, let's say we had the function y is equal to 3 sine 4x. And we were asked to find the amplitude of this function and also the period of the function. And we're looking for the period in degrees. Well, the amplitude is easy. It's the number here before the sign. So the amplitude, we'll just call it A, is equal to 3. Now, the period we know is wrapped up in here. But we know it's a sine function. We know the sine function repeats every 360 degrees. So what we could say here is 4 times x is equal to 360 degrees. So we can say that the period x is equal to 360 divided by 4, which is equal to 90 degrees. So the amplitude of this function is 3 and the period is 90 degrees. So in effect we're going to get 4 of these sine functions over a period of 360 degrees. So we'll go through a lot more examples in the example video. That's all for this video. Thank you for listening. Goodbye.